8.3, special right triangles. One of my top 5 favorites of the whole year today. Get ready. All right, but first, let's warm up and review over Pythagorean theorem in 8.2 because we have a quiz on Friday. A 20-foot wire is tied from the top of a flagpole to a stake in the ground. And if the stake is 7 feet from the base of the flagpole, 20-foot wire, find the height of the flagpole. Hopefully our flagpole is standing up straight, and this is a right angle. I'm going to call it X. Okay, so I like to draw a picture. And to find that missing side length, because this is a right triangle, I can use Pythag. And my 2 legs squared, their sum equals the hypotenuse squared. So let's see here, doing some quick math. 7 squared is 49, 20 squared is 400. Subtract that over, you get 351. Square root both sides. Okay, I do want to say, because I'm going to be gone when you're taking your quiz, please make sure you read the directions on your quiz, because I know there's some problems that say, like, leave your answer in simplified radical form and give me the decimal. Okay, so just make sure you're reading the directions. In this case, when we're talking about feet, we usually want decimals. So it's about 18.7. You can just round to 1 decimal point feet. Would be the height of our flagpole. Okay, classic Pythag word problem. The next set of problems said to determine whether each set of side lengths represents an acute, obtuse, or right triangles. And I remember on the quiz, it says, like, justify your answer. So let's walk through what that looks like. First of all, we have to make sure it's even a triangle. And I told you could take the shortcut of just adding together the 2 smaller sides and making sure that their sum is larger than the third side. Because if that's not true, then it's not even a triangle to begin with. All right, so this you're testing for a triangle. So this one is a triangle. The sum of the 2 smaller sides is greater than the third. So then to determine what kind of triangle is, we do a little like version of Pythag. We take the 2 smaller sides and we square them, add it together, and we look at how that compares, so I like to do question mark, to the third side squared. And this is everything you need to know, or need to show when I ask you to justify your answer. Like your work right here, this is just fine. Yes, it's a triangle. This is why I think it's a right triangle. Okay? All right, in this case, 8 squared plus 14 squared, I got 260. And 16 squared was 256. If they're equal to each other, that means Pythagorean theorem is true, and it's a right triangle. These are not equal to each other. These 2 smaller sides, their sum is larger than that third side squared. So do you guys remember what kind of triangle it is? It's acute because that third side is like smaller than the other 2. So that's acute. So that's, if you show those steps, that's perfect justification. You don't need to like write out any words. All right, so next one's similar. First, test if it's a triangle. Yes, it is. Okay. This time, when I do my little version of Pythag, I get both sides to be the same, 225. Which means Pythagorean theorem is true, which means it's what kind of triangle? Right triangle. My green one kind of works. You can put it on my desk. Thanks, Ashton. Okay, so that's a review. Now I'm so excited to show you 2 special right triangles. And I'm telling you, we use these all the time in pre-calculus. These 45, 45, 90 triangles and 30, 60, 90s. So, this is important stuff. Okay, I'm going to do a little mini, like, not really a proof, but kind of like an algebra proof, an algebraic proof of where these, like, special relationships come from. All right? We're going to start actually over here with a square. This is a square. What do we know about squares? All the sides are the same length, and all angles are what?
90 degrees.
90 degrees. Good. Everybody draw that. Okay. We also know in a square, the diagonals bisect the angles, meaning each of these angles would be how many degrees? 45. Good. Okay, so I'm just going to label these two. And so I'm going to highlight here. We have this right triangle using the two side lengths as my legs and the diagonal as my hypotenuse, and this is a 45, 45, 90 triangle. All right, I'm going to say that the length of one side is L. So let's say this is L, then this is L. They're all L. But we're just looking at the one specifically, the triangle. So let's do Pythag to find the length of the hypotenuse. I'm going to call it C, since it's the hypotenuse. So we would do my two legs squared and add it together. And that's going to equal my hypotenuse squared. All right, I'm going to solve this for C. Don't get confused with all the letters. L squared plus L squared is 2L squared. Write this down. How would I get C by itself, aka like solve for C in this little equation? Square root. Good one. So I'm just going to move this C over here. I'm going to square root both sides. When is right, that would just give me C. Okay, over here, this looks weird. Square root of 2L squared. Let's break it up just like we do with radicals. That's the square root of 2 times the square root of L squared. And if the square root of C squared is C, what do we think the square root of L squared is? L. So C, I'm going to bring the L in front, is L root 2. Here's the special relationships in 45, 45, 90 triangles. Whatever the leg lengths are, the hypotenuse is always that length times the square root of 2. Every time. Obviously, in a 45, 45, 90, it's an isosceles triangle. The legs have to be the same length. So let's say they're 7. This is 7, this is 7. Then the hypotenuse is always going to be 7 root 2. Every time. And then obviously you could like do Pythag and see that that works. Okay, so there's our first special type, 45, 45, 90. The next one, I'm going to give you this triangle. This is an equilateral triangle. What do we know about equilateral triangles? All the sides are the same length and all the angles are how many degrees? 60. They're all congruent, 60. Okay. So I'm going to draw an altitude of this equilateral triangle. I'm going to go from the top to the base here. And what we know about equilateral triangles and these altitudes is that they bisect this angle. So this would be 30 degrees right here. My markers have been kind of wacky today. I got some new ones and they're kind of weird. 30 degrees. And we also know that it bisects this side. So here's my little triangle in this big triangle. I have a 30, 60, since this is a altitude, that'd be a right angle. 30, 60, 90 triangle. All right, this time I'm going to say that this little segment is a length of S. So remember, it bisects that side. So this whole side would have a length of what? 2S. Yep. So this side length is going to be 2S. This one. Let's figure out what this altitude would be. I'm going to call it H. So using Pythag, my two legs squared, so S squared, plus my other leg is H, equals this hypotenuse, which is 2S squared. Okay, I'm going to solve this for H. Algebra. 2S squared is 2S times 2S, 4S squared. solving this for h, and I see I have like terms here, so I'm going to move this s squared over. And I have h squared is the same as 3s squared. Almost there. How would I solve for h? Square root both sides. All right. So that would give me h. The square root of 3 I can't simplify, but the square root of s squared is just s. So I'm going to bring it out in front. So here's your special relationships in my second special triangle called a 30, 60, 90. Whatever the side lengths across from the 30, let's say it's 5, the hypotenuse is always going to be double that, so the hypotenuse would be 10. And the side across from the 60 is always going to be the square root of 3 times that. So it'd be 5 root 3. So that's going to hold true no matter how like big or small the triangle is, no matter like the scale. And here's what you have to know. And I remember seeing this somewhere on an assessment. I don't know if it's on a future quiz or maybe the chapter 8 test, where I give you 2-point triangles and you have to fill in these special ratios. So you have to memorize these, but it's not hard. Okay? I use the variable L for 45, 45, 90. It's what your textbook uses, so I just kept it the same. And I use S for 30, 60, 90. Okay? So here's what you need to know for 45, 45, 90. The legs are always going to be congruent. It's isosceles triangle. We talked about isosceles triangle theorem, that if these are congruent, the sides opposite are also going to always be congruent. So we call those L and L. And then across from the hypotenuse is L times the square root of 2. That you need to memorize. However you need to memorize it, it's up to you. But you need to know it. 30, 60, 90 is just a little bit more challenging. But here's how I remember it. And I use S's. I start with the smallest angle, which is 30. So across from the smallest angle is the smallest side, it's just S. And then I go to my hypotenuse. So the one across from the 90 is always going to be double what that is. And then the one across from the 60 is always going to be the square root of 3 times that. Okay. We're just going to try a bunch of example problems. That ratio is always going to hold true no matter what a side length is. Here's also the tricky part. Sometimes you might not be given like what is across from the 30. Maybe you're given the hypotenuse, and you have to do a little like working backwards. Like I said, it's like a puzzle to figure out the other side lengths. And we can't use Pythag on these. Look at the first example. I have 2 unknowns. So I can't do Pythag. You're like, where's my variable? So we can use the relationship here because look, I have a 45, 45, 90 triangle. So every single time you guys do one of these problems, of these special right triangles, I want you to write in these special ratios on your picture. Okay, so on a 45, 45, 90, the first thing I would do is across from the 45s, do L, L, and across from the 90, do L root 2. Okay. Now, sometimes you might be given what L is or what one of the side legs are, side lengths. But this time I'm given what the hypotenuse is. The hypotenuse, which is 8, is L root 2. So what I'm going to do is I'm going to say, okay, L root 2 is 8 in this case, and then you can algebraically solve for this L. So think of this like an equation. You have L times the square root of 2. So divide both sides by the square root of 2. And I threw some of these in here to review over something we call rationalizing denominators. You guys remember what's wrong with this number right now? Go ahead. Beautiful. Can't have square roots in the bottom. Who remembers how to get them out? Oh, we just went over this. Yes, multiply top and bottom by the square root of 2, whatever your denominator is. Why we do this is because on bottom in my denominator, I get the square root of 2 times the square root of 2, and 2 times 2 is 4. It's always going to make your denominator a perfect square. So, square root of 4 is 2. Radicals are gone. All right? Up top, 8 times the square root of 2, you just write like this. You can't multiply those together because the 2 has a radical and the 8 does not. And on bottom, you have the square root of 2 times the square root of 2, which is the square root of 4, which is 2. Okay? Or, folks, think of it this way. The square root of 2 times itself twice is this, and that undoes that. You're just left with 2. All right, now because 8 and 2 are both whole numbers out here, we can divide them. So L ends up being 4 root 2. Now, they technically didn't ask me what L is, they asked me what A is. So I go back to my picture, and I'm like, well, A is just whatever L is. And if L is 4 root 2, then A is 4 root 2. I could check my answer by doing Pythag. Okay, that was a 45, 45, 90 example. Let's try a 30, 60, 90. Look here, again, 2 unknown lengths. I can't do Pythag here, especially not in this one, because I have 2 variables. Can't do x squared plus y squared equals 17 squared. I'm not going to be able to solve that. But I see that one of the angles is 60 degrees and the other is 90. So what does this third angle have to be? 30. 180 minus 90 minus 60. It has to be 30. So we have a special right triangle, 30, 60, 90. As soon as I see that, I'm going to write down my special ratios. Across from the smallest angles, S. Across from the hypotenuse is double S. Across from the 60 is S root 3. You'll do so many of these problems, you'll start to accidentally memorize it. All right, so now I'm going to check what's given to me in this case. And again, the hypotenuse is given to me. But this time, the hypotenuse is 17 is equal to 2S. Everybody see that? And if you label it right there, there's your equation set up for you. You just got to add in the equal sign. So now I can figure out what S is. S is 17 halves, and if you write it as 8.5, that's fine. S is 8.5, or 17 halves. And then I look at my picture, and I'm like, well, Y is just whatever S is. And if S is 17 halves, or 8.5, that's what Y is going to be. Because your hypotenuse is always going to be double that. So the side across from the 30 is always going to be half the hypotenuse. And then lastly, to find X, I see that X in this case is S root 3, and S is 17 halves times the square root of 3. And the square root of 3 is a fraction, so the square root of 3 over 1. And when you multiply fractions, you multiply the numerators, multiply the denominators. So you 17 root 3 over 2. And when it has irrational numbers like that, we want to leave it in the exact radical form. We don't really want decimals. Okay, so it's 17 times root 3 over 2 times 1. And then obviously I can't really reduce this. I wouldn't recommend doing 8.5 root 3. We don't usually write like decimals and radicals together. Okay, we're going to try a bunch more because it kind of just takes some practice. But it's like a puzzle. And these are fun. What kind of special right triangle is this one? 45, 45, 90 or 30, 60, 90? 45, 45, 90. Good. So as soon as I see that, I'm going to go ahead and do L. L on my legs. On the hypotenuse, what do we have? Not 2L. L root 2 for 45, 45, 90. L root 2. That's okay. I don't expect you to have it memorized yet. This time I'm given that L is 9. I don't even have to do any solving to find L. L is 9. So X, my hypotenuse, is L times root 2. So X is just 9 root 2. That's all I gotta do for that one. Easy. They asked you to find the other side, this one, that would also just be 9. Ooh, good question, alert. What kind of triangle is this one? It is a right triangle. Is it a 45, 45, 90 or a 30, 60, 90? Okay, Tyson says 45, 45, 90. How'd you know that? You're right.
It's isosceles, which means angles opposite are also equal.
Yes. I hope the viewers at home heard that. He said it's an isosceles triangle. These are congruent. They're both 6 root 2. So the sides opposite then have to be congruent, and they have to total 90, so they both have to be 45. Nice. Okay, another 45, 45, 90. L, root 2. That's how you fill that in. L, root 2. All right, so look what's given to me. L is the same as 6 root 2. So X, which is L root 2, I'm going to have to plug in what L is, which is 6 root 2. And then I have to times that by root 2. L is 6 root 2, and that's the relationship there. Okay, so here I have 6 times the square root of 2 times the square root of 2, which is the square root of 4, which is 2. X is 12. Okay, starting to kind of see it. Let's do another one. 30, 60, 90 or 45, 45, 90? 30, 90. This has to be 60. Okay, you guys shout out the letters. Across from the 30, S. Across from the 90, 2S. Across from the 60, look, you guys already have it memorized. Some of you. S or 3. All right, what am I given? Ooh, nice. I'm given S. No solving needed. It's not a nice number, but S. Maybe I can't have both markers picked up at the same time. Maybe that's the issue. S is 4 root 3 over 3. Okay, I'm actually going to find Y first. Y looks pretty easy here. Y is just 2 times S. So since S is 4 root 3 over 3, 2 times that, and if it helps you to write 2 as a fraction, you can. It's 2 over 1. 2 times that is 2 times 4 is 8 root 3 over 3. Would be the algebra there. Okay. X is S times the square root of 3. S is still 4 root 3 over 3. So times by the square root of 3. Again, if it helps you to write that as a fraction, you can. All right, let's do some math here. 4 times the square root of 3 times the square root of 3, which is the square root of 9, over 3 times 1 is 3. So you get 4 times square root of 9 is 3. So 12 over 3 is 4. Okay. The next one is not a triangle, but it's a square. And I'm shown here that I have a right angle. And so looking at this triangle with these two congruent sides, this would be a 45, 45, 90 triangle right here. Which means this triangle would also be 45, 45, 90. You can see that those corners have to be 90 degrees. So X is just 45 degrees. That's all I had to find for that. But to find Y, I'm going to look at that blue right triangle. And I see 45, 45, 90. So I go L root 2. All right. I look what's given to me. Ooh, nice. L is 12. So Y, that's what I'm trying to find. Y, which is L root 2, and L is 12, would just be 12 root 2. That's it. Okay, any questions? Let's try one that's just a little more like challenging. This is a really cool one. because it has both of your special right triangles in one diagram. If I look at this one right here on the left, it's a 30, 60, 90. And if I look at this one right here, it's a 45, 45, 90. All right. Let's find X first. Last hour I did it the other way. Let's do it this way. All right, let's start with this 45, 45, 90. So I know it's L, L, L root 2 for those ratios. Okay, I see what's given to me. And L root 2 is 18. So all I got to do is find L, because X is the same thing as L. Let's do it. So divide by the square root of 2. Oh, another one I got to rationalize. Times the top and bottom by whatever the denominator is. So the square root of 2. So up top we get 18 root 2. On bottom we get the square root of 4, which is 2. And then I have 18 divided by 2, which is 9. So since L is 9 root 2 and X is whatever L is, X is 9 root 2. Okay. Now perhaps like the, I guess like tricky part of this question is now when we look at the other triangle, the red one, 18 is no longer L root 2. I'm actually going to make this, oh, whoa. I'm not going to do that. I'm going to make it green. Okay, 18 is no longer L root 2. Because now if we look at it in this triangle, in a 30, 60, 90, across from the 30 is my smallest s, across from the hypotenuse is 2s, and across from the 60 is s root 3. So this time, 18 is s root 3 for that triangle. So you gotta be careful with that. So similar to the last one, s root 3 is 18. We gotta solve for s. Okay. This time, folks, what do I gotta multiply the top and bottom by? Square root of 3. Yep, square root of 3. So you get 18 root 3 over the square root of 9, which is 3. 18 divided by 3 is 6. Okay, but that's just s. We're not done yet. I don't mean to go too fast with that. It's just a lot of them are the same kind of algebra. And don't worry, as always, you guys would practice. Okay, so I'm probably going to find y next, because y is just whatever s is. So y is 6 root 3. Z is 2 times whatever s is. So double 6 root 3 is 12 root 3. Okay. The next two examples are very similar. You're just not given a picture. All right, so let's take a look at this first one. It says, if a 45, 45, 90 triangle has a hypotenuse length of 12, find the leg length. Okie doke. So we know it's a 45, 45, 90 with the hypotenuse length of 12. So on a 45, 45, 90, L, L, L root 2 for the hypotenuse. All right, why don't you guys go ahead and see if you can find L. All right, in this case,
Excuse the interruption. Jaden Glassbrenner and Lily Conley, please report to the office. Jaden Glassbrenner and Lily Conley.
Okay. So I know the hypotenuse is 12, which is L root 2. So solving for L, you have to rationalize again. My markers are so whack right now. Square root of 4 is 2. Simplify that. 12 divided by 2 is 6. And that's all I asked you to find was the length of the leg. Okay. Not too bad. Just takes practice. The next one's very fun. We only have 2 more to go, guys. Hang in there. And then this is the last of the notes for the whole week. When we come back Monday, you know I said this is like my top 5 favorite. Monday's lesson is probably my number 1 favorite. So, coming off of prom, you have something to look forward to. I saved it just for that day. All right. This one says, an equilateral triangle has an altitude of 45 centimeters. Determine the length of the side of the triangle. All right. Equilateral triangle, we know all sides are congruent, all angles are congruent, and they're all 60 degrees. So the altitude, I'm just going to draw the altitude from the top to the bottom. We know bisects that angle. You okay, Gwen? Somebody's scared. Bisects that angle of 30 degrees. It's an altitude, so it's perpendicular to the opposite side. And we know that has a length of 45 centimeters. And we know it splits this side in half. Okay, so I zone in on this triangle because I'm like, hey, this looks like one of my special right triangles, specifically 30, 60, 90. Crossing the 30s, S. Crossing the 90s, 2S. Crossing the 60 is S root 3. What we're trying to find is the length of the side of the triangle. So we're trying to find what 2S is. All right, so if we know that S root 3 is 45, we can find S, double it, boom. There we have the side of our triangle. All right, gotta rationalize again. You're gonna get so good at rationalizing denominators, guys. All right, S is 15 root 3. So to answer the question, the length of a side is just double S. So double 15 root 3 would be 30 root 3 centimeters. Questions? All right, I'm going to let you guys try this one while I pass out the worksheet. Triangle XYZ is a 45, 45, 90 triangle with the right angle located at vertex Z, vertex V. Find the coordinates of X in quadrant 1 or where Y and Z are positioned. Give it a whirl. Anyone have a guess?
6, column 9.
6, 9. Any other guesses? I'm hearing this. Anybody else get that? That is right, if you got that. All right, let's quick go over it. So y is at -1, 2. Z is at 6, 2. And we know the right angle is at Z. So here's one side of my triangle. So I know it either goes this way with the right angle or this way, but I know X is in quadrant 1, so it has to go this way. Okay, Matthew, how'd you figure that out? How'd you know to go up to 9?
Because the 2 legs are the same length.
Good. So we just said the legs have to be congruent. So this was how long?
7.
7. So we counted 7 up. Puts my right angle at Z. And there you have it, folks. That'd be at 6, 9. Awesome. That's a wrap on 8.3. Ooh, we finished 4 minutes.